scientists have actually detected vibrations from colliding black holes in outer space. Let me begin by breaking it down. Back in 1915, Einstein proposed a theory of gravity that said that gravity is actually due to the fact that space-time is like a fabric that can stretch. And if you are then moving along the fabric, then your path is bent sideways or whatever, just like what gravity does. And just like the surface of a pond now, if you were to throw a rock into a pond, you get ripples forming on the surface of the pond. And then Einstein said, well, gravity must be like that. If I have a tremendous disturbance, then shock waves should emanate from the impact, and we should be able to observe that with our instruments. However, he did a quick calculation, and he quickly realized that in his lifetime, he would not be able to detect these gravity waves. So this went on for 100 years, from 1916 to 2016. For 100 years, scientists have tried to look for gravity waves. And they did it by building a gigantic machine called LIGO, two of them, one in Washington State and one in Louisiana. It's basically two laser beams that form a joint. It looks like an L. When these two laser beams collide, they form an interference pattern, just like the interference pattern you get on the surface of your bathtub if you make waves on the surface of your bathtub. Well, if there's a colliding black hole in outer space, it creates waves. These waves then hit the laser beam, jiggle the laser beams, and then our instruments are sensitive enough to be able to detect the fact that they've picked up the vibrations. Then you can take these vibrations, run it through an audio amplifier to get sound waves coming out of it. Now, the media call this the music of the spheres. That is music from black holes. Actually, it's not anything of the sort. But, if you stretch your imagination a bit, what we're talking about is gravity waves from space-time itself jiggling a diaphragm, and the diaphragm then jiggles air waves, giving you sound.